Hello, 8th grade. Today I'm going to go through the information for density of regular shaped objects. So the essential questions we're looking at is how do you calculate the density of regularly shaped objects? That would be things that you could measure the sides of, not like a rock or something that's irregularly shaped. And how can calculating density determine the identity of an unknown? So, as you know, to calculate the density, you take mass and you divide it by the volume. Now, on the liquid lab, we were measuring in grams per milliliter because it was liquids, but often density is measured in grams by cubic centimeters. And that would be like a block that is a centimeter by a centimeter by a centimeter. So, answer this question. Now, density of regular objects. So volume is the amount of space taken up by a quantity of matter. And we measure that in cubic centimeters or cubic meters. And if you have a cubic centimeter of water, that actually equals the same as 1 milliliter. So with the metric system, we're able to make conversions much easier. So answer the question. Now, to figure the density of regular objects, you need their volume. So, as you probably remember from math, the volume is determined by measuring the length, the width, and the height, and multiplying those together. So here we have a prism. So you're going to multiply the length, the width, times the height. You need to show your work in this box right here. So you are going to include the formula you used and the unit labels. Remember, if it's just a number, then it doesn't represent anything. The numbers all need to be labeled in science. So mass is the amount of matter in an object, and you can use a triple beam scale, a triple beam balance or a scale. And in science, we measure them in grams and milligrams. So why do scientists use mass instead of weight when calculating density? Imagine that you are on the moon. So your weight is actually a measurement of the gravity pull on you. On Earth and on the moon, you would have the same amount of mass, but your weight would be different because it would be dependent on gravity. Okay, so now you're going to do this density problem. We have the mass. You need to calculate the volume and tell me the density and make sure you put your work in that box. Include the formula and make sure you label the units. Now, pay attention because this is meters times meters times meters. So this particular prism will be in cubic meters. Okay, so we have a real world problem. A golden colored cube is handed to you. The person wants you to buy it for $100, saying that is a gold nugget. You measure the cube and find that it is 2 centimeters on each side and the mass is 40 grams. So you're going to put the volume of the cube here. You're going to calculate the density of the cube here, and then you'll compare it to this chart. Now, if we look here, gold is right here. So if it was gold, it should have a density of 19.3 grams per centimeter squared. Is it gold, and should you buy it? Okay, so here you just need to answer these questions. It's basically what we've been covering all along. You're going to put the formula here. Has the mass and the volume. Solve the equation. Basically, you're just going to put mass over volume. And here, this is about whether or not this will float in water. So, water has a density of 1. If it's above 1, if the density is above 1, then it will sink. If it is above 1, it will float. I'm sorry, if it's below 1, it will float. So if the density is above 1, it'll sink because it's more dense than the water. If it's below 1, it will float. So density of material remains the same regardless of how much the material is present. So we have two material here. It's the same material, but different sizes, but the density remains the same. And that's why we actually divide mass divided by volume, because it will be the same no matter, the density will be the same no matter what size that particular object is. So you're going to calculate the volume of the rectangular prism and calculate the volume of the cube. Each ball is 1 centimeter, so you're going to have to count the balls to see to figure out the volume of each of these prisms, and then show your work and tell me how the density compares here. Here, a block of lead has dimensions of 4.5 centimeters by 5.2 centimeters by 6 centimeters. The block has a mass of 1,587 grams. So for square 2, you're going to calculate the density. For square 3, if you cut the block in half, what would be its density? And tell me how you found that answer. So temperature does affect density. When heated, molecules move faster and slightly apart. So the mass will stay the same, but the volume will get larger, and it results in decreased density. So you're going to look at these 3 pictures. You're going to look at which one has the greatest density and which one is the least dense. Here we have 3 different liquids. They're going in the same container. There's 15 milliliters of each liquid. X has a mass of 30, Y has a mass of 52.5, and Z has a mass of 11.25. So you're going to calculate the density and predict how the 3 liquids will separate into layers, and you're going to explain that here. For your last look, you're going to answer the questions about these regularly shaped objects, A, B, and C. If you place all 3 objects in a beaker of liquid with a density of 5 grams per centimeter squared, how would the objects be arranged in the liquid? So the most dense would be at the bottom, the least dense would be at the top. You're going to drag these blocks into the liquid so that we can see what position they would be. So you're going to have to figure out the density of all 3, and then you're going to move these blocks in order of where they would be in the liquid. Give your best answer to these 2 questions, and if you still have any questions, then you can ask them here. I hope that this made sense. If you have any questions, as always, please reach out and ask. Thank you.